On lesson 31 of pre-calculus, unit 6.1 in the pre-calculus textbook, page 343. We're going to talk about angles in radian measure. So far, what we've done our measurement in is degrees. Now, how did we define what a degree is? Where did that come from? Do you remember that? The Babylonians, in an equilateral triangle, we know that an equilateral triangle is also equiangular, and each angle of an equiangular triangle is 60 degrees. And so they said, we're going to let 1 degree be equal to 1/60th of that angle right there. So they defined the size of a degree as being 1/60th of the angle size of an equilateral triangle. So that standardized for the rest of the world as we know it, what 1 degree represented. So if you say, well, how big is a degree? It's a 60th of the angle of an equiangular triangle. That's how big it is, okay? Now, we talked about the unit circle, and that's a circle with a radius of 1. Remember that? And we said if we do that, then we could make an angle. And remember that each of these little marks right here is like 15 degrees. So we got 15, 30, 45, 60, 75, 90, if you follow those little grid marks. Then what we want to start doing today is talking about radians. And so how do we define a radian? Well, the way we have defined degree is the amount of rotation between the initial side and the terminal side in degrees. And we said that a circle was 360 degrees. But there's times that we don't need to really consider how big that angle is according to the amount of rotation that has occurred. We need to think about how big that angle is in relationship to how far around the circle we went. In other words, could we talk about angle measure in terms of arc length, how far around we went? Now let me just show you what I'm trying to say here. What is the formula for the circumference of a circle? That's area. Circumference is 2 pi r. Circumference is 2 pi r. Now, what if the radius is 1? Are we not talking about the unit circle here? What if the radius was 1? What would you have? 2 pi. So if we're in the unit circle, which is the foundation of geometry rules, then we could say that the circumference is 2 pi. Now, pi is 3.14 bloody. So 2 pi would be 6.28 bloody. And so we could say in this unit circle, in this circle with a radius of 1, the distance around that circle is 2 pi. Now, how many degrees around is it? 360 degrees around. But how far around is it? It's 2 pi around, okay? You see the difference? We're talking about the angle in terms of degrees of rotation with 360, but we're talking about it in terms of length when we're talking about radians, okay? And so we say that there are 2 pi radians. I'm going to clear that up because my R got in with my T there. We would say that there are 2 pi radians in a circle. 2 pi radians in a circle. So in a degree, I'm trying to just make this make sense to you. If we're talking about an angle measure in degrees, we're talking about clicks. How many clicks of rotation? We could say, well, there's 60 clicks of rotation, okay? out of 360 possible clicks of rotation. When we're talking about radians, we're not talking about clicks of rotation. We're saying parts of that circumference. How many parts of the way around are we when we're talking about radians? Okay? So we're actually talking about length, not just rotation when we're talking about radians. And that becomes important to us sometime. Now, the fundamental thing that we've just created, we actually tried to make a decent definition of degree and radians, but we also found a relationship. We found out that a circle is 360 degrees, and we also found out that that's 2 pi radians. Well, if 2 pi radians is 360 degrees, then how many radians would be 180 degrees? Half of that, which would be pi radians. Well, how many radians would be 90 degrees then? Half of that. How many radians would be 45 degrees? Half of that. Now, to avoid fractions and as much whole numbers as is possible, if we're gonna do a conversion between radians and degrees, the easiest conversion is to say that radians is 180 degrees. That avoids the fractions and it avoids the bigger numbers. And so this is going to be our foundation of conversion. We're going to use that like we use 1 foot is 12 inches or 1 minute is 60 seconds. We're going to convert from one to the other, and we're going to convert using dimensional analysis. Okay? Okay. So for just a moment then, let's go to our worksheet. We're going to go back and forth a little bit today. So if you'll move to your worksheet there. I'm just going to write over the top of this unit circle. Question number 1 says, change each degree to radian measure in terms of pi. So we start with 210 degrees. Now, our conversion is that our conversion that we're going to use is that pi radians is equal to 180 degrees. Pi radians is 180 degrees. Now, remember our dimensional analysis? We're going to put what we started with over 1. And we're going to multiply such that we, how do we say this with dimensional analysis? Such that we lose the name degree and gain the name radians. We're going to write down what we started with, and we're going to multiply such that we lose the name degrees and gain the name radians. And then we look at our conversion. Pi radians is 180 degrees. We're converting from degrees to radians. Lose the name degree, gain the name radian. All we needed to know was our conversion factor. Okay? So we're going to have to cross-reduce. What's the greatest common factor between 210 and 180? 30. So 30 goes into 210, 7. 30 goes into 186. And so we end up with 7 pi over 6 radians. So 210 degrees is 7 pi over 6 radians. Now, we're going to talk about the circle and how we kind of get an idea of what quadrant is that in. Because some of you later will say, oh, 7 pi over 6, where's that at? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. How do you know real fast what quadrant that's in? Well, we're going to kind of start thinking, well, there's pi, How many sixths is pi? 6/6 or 3/3, right? 7/6 is just a little over 6/6, so it's sitting over here in quadrant 3. We're going to have to start getting a mental picture of that. So you got to know some fraction stuff. Like you can't just punch it in the calculator. You got to visually go 7/6. That's a little more than 6/6. 6/6 is pi. Pi is 180. I'm a little past 180. Quadrant 3. Okay, that's got to start clicking around in our head. Okay. Example 2. Number 2, we have negative 450 degrees. We're trying to go from degree to radian. So we need to multiply such that we lose the name degrees and gain the name radians. And then all we need is our conversion. Pi radians is 180 degrees. Cross reduce, what's the greatest common factor? 90. 90 goes into negative 450, negative 50 times. 90 goes into 180 2 times. I should have divided. Whoops, did I make a mistake? That should be 5 instead of 50. We knew that. Thank you. Divide by 90, and we get 5. Divide by 90, and we get 2. So we get negative 5 pi over 2 radians. Now, negative means that we're going clockwise instead of counterclockwise, right? Any questions on number 2? Going from degrees to radians. Okay? About where would that be? How many half pies make a whole pie? Okay, let's think about this. This is 2 over 2 and 2 over 2 and 1 over 2, right? Now we're going negative. 2 over 2 is that, right? Another 2 over 2 is that. And a 1 over 2 is that. See where we did? Okay. So you got to start visualizing. We're going clockwise. And so 2 pi over 2 is pi, and pi is a semicircle. So we had 2 semicircles, which is a whole circle. And then a half of a semicircle, which puts us back at the 3 pi over 2 if it was going the other way, or 270 degrees, okay? A quadrantal angle. So we've got to be able not to just convert it, but to think about how it's making its way around that circle. Okay, number 3 and 4, we're starting with radians and going to degrees. Also, number 3, we have 3 pi, start again, 11 pi over 3. Those got blended together, didn't they? 11 pi over 3. We started with radians. You can just kind of think, well, it's understood radians. It doesn't put the name. If you see a pi symbol, you're in radians, okay? Now we're going to lose the name radians and gain the name degrees. And we know that 180 degrees is pi radians. 180 degrees is pi radians. Now, the understood radian name cancels the understood radian name, and the understood pi, the pi cancels the pi. So we're going to have 11 times 180 divided by 3. Well, 3 will go into 3 once, and 3 will go into 180 60 times, and 60 times 11 is 660, and so we're going to get, the pi's gone. We're going to get 660. We lost the name radian, and we gained the name degree, so we have 660 degrees. Any questions on that? We cross-reduced. Somebody asked what happened to the 3. 3 went into 180 60 times. We cross-reduced. Any questions on number 3? Very good. Okay. Number 4. Number 4, we started with negative 3.5 radians. It told us it was radians. There's not even a pi symbol. What's wrong with that? Is there anything wrong with that? What is pi anyway? Pi is just a number, 3.14. So 3.5 radians is just a little over pi, because pi is 3.14. Okay? We could have made some crazy fraction pi, but they just said 3.5. It's understood that that's just that value, and it's given in radians, okay? Now, we need to lose the name radian and gain the name degrees. Radians was understood there. It told us it was in radians. 180 degrees is equal to pi radians. Now, we're gonna put the pi symbol, but we know that pi has a value 3.4. And we're going to use that when we do our calculation, okay? And so we're going to cancel our radians with our radians. And so how are we going to solve that? We're going to take negative 3.5 times 180 and then divided by pi, correct? So you just stick that in the calculator, negative 3.5 times 180. Divide pi. To get pi, you hit second and the little housetop thing. Is that right? And you get negative 200.5 degrees. Rounded, I assume. Was that rounded or is that exact? Okay. Rounded to the nearest tenth. There we go. Okay. What I wrote's rounded. Got you. Okay, any questions on number 4? So the first thing we learned today, radian measure, the way I think of it, it's like a click of the circumference. It's really thinking about the size of an angle in relationship to the length of the circumference instead of the amount of rotation in a circular motion. And it gives us a way later to do some calculations that are handier, to really get a length answer rather than something with degrees all tangled in it. Okay? All right, any questions so far? Now, what we've got to do now is we've got to take this information and we've got to apply it to our unit circles. We're going to go back and recreate our unit circle ideas again with all of our degrees and things in it. Now, we're just going to go off of memory work. So 0 degrees would be the same as how many radians? 0 radians. If we went to 30 degrees, here's my 30 degrees. 30 degrees would be how many radians? Did you figure something out? This is going to be important. Y'all make sure you catch this. If we were to convert, watch what happens when we convert. If we were going to convert 2 radians, we would say, okay, I'm going to say I need to lose the name degrees. I need to gain the name radians. My answer when I convert to degrees to radians is going to have a pi on it. But how am I going to get that number? Well, 30 goes into 186. Pi over 6. Now this is important. You need to quickly be able to say, do not. I hit yes. It is recording. We're still going. Okay. No, I did not want to delete that. We had a little temporary pause there. Okay. So this is what I need you to quickly be able to think in your mind. We need to be able to think 30 degrees. What's that going to look like as a fraction of radians? Well, 30 is going to go into 186. So if you want to know what the denominator looks like with a 30-degree angle, you're going to go 180 divided by 36. That's what my denominator on my pi is going to look like. And it's going to look like that for every reference angle that goes with it. Okay? Now, let me do another. Let's just keep building this thing for just a moment. Okay, so we know that 30 degrees is pi over 6. Okay, now 30 degrees has a reference angle. You see, this angle right here is 30 degrees from 180, right? How many degrees would that angle be? 150 degrees. So 150 degrees in quadrant 2 has a reference angle of 30 degrees. That was in quadrant 1. So they have the same sine value, even the same sign of sine, because sine's positive in quadrant 2. But let's just convert that. Let's look what happens when you convert it. 150 over 1 times pi over 180. 30 are going to 150 5 times. 30 are going to 180 6 times. You get 5 pi over 6. Did you notice that when I have a 30-degree angle, I have a denominator 6. 30 times 6 is 180. And if I have an angle whose reference is 30, I still have a denominator of 6. That means anytime I have a denominator of 6, I have a reference angle of 30. Okay? Now, do you see how that's developing? Okay, so let's move to 60 degrees. If I had an angle that was 60 degrees, 60 degrees, here we go, let me get in the right spot, then what would that be in radians? Well, I would multiply by pi over 180. What's my denominator going to become? 60 goes into 183. So I'm going to end up with a pi over 3. The denominator times the degree is 180. 60 times 3 is 180. See how quick you can find out what that is? So we'd say, well, we got pi over 3. What's that as a degree? Well, 3 times what's 180? 60. So it's 60 degrees. Okay? So then you think, well, what about over here? Over here in quadrant 2, if I were 60 degrees away from 180, I would be right here. And if I'm 60 degrees less than 180, I'm at 120 degrees. And what would that be in radians? Well, I'd take my degrees times pi over 180. And I'd say 60 goes into that 2, and 60 goes into that 3. And so I end up with 2 pi over 3. Did you notice that anytime I have a denominator of 3 on my radians, my degree reference angle is 60, because 60 times 3 is 180. And even if I have a reference angle in another quadrant, it still has a denominator of 3. So anywhere you see a radian denominator of 3, you have a reference angle of 60. Now let's just stop on that one for a second. Let's say, well, what if we wanted cosine? What is the cosine of pi over 3? Well, what's the cosine of 60? We're supposed to have that memorized. Everybody was supposed to say 1/2 all at the same time. What is the sine of pi over 3? Well, pi over 3 is the same as 60. What's the sine of 60? We got lots of memory work to do. Square root 3 over 2. From memory. We're supposed to have it memorized. Everybody in the class already. If we said, okay, what is the tangent of 60 degrees? Square root of 3. And so what we have to be able to do now is know all of the answers to that memory work in degrees and radians. But it's not that hard to convert from radians to degrees. If there's a 3, what's the degree? 60. 3 times 60 is 180. If there's a 4, 180 divided by 4, 45. If there's a 6 in the denominator, 180 divided by 6 is 30. See that? And then everything else we've already memorized. Okay, so we're going to play with this a little bit. We're just going to play games on the circle just to practice everything we're supposed to have memorized. Now, those of you who haven't memorized everything you're supposed to know in trig so far, you better watch out because you're going to start making 2s and 10s and 20s on trig tests. It's going to get very ugly if you don't start your memory work. You have to do it promptly. Let's just say that we had negative 7 pi over 6. Now, let's just do 7 pi over 6. I'm sorry. 7 pi over 6. Where's that at? It's in quadrant 3 because this is pi, and it's 1 pi, and 1 is 6/6, and so we're a 6th over pi. Now, what angle measure, one second, what angle measure goes with a 60-degree denominator? 30 degrees, because 6 times 30 is 180. So we're actually setting right here. We're 30 degrees past pi. We're at 7 pi over 6. We're 1/6, 30 degrees over pi. So my reference angle is pi over 6, which is 30 degrees. Now, let's say I said, well, what is the sine of that? Well, the sine of 30 is a half. And, there you go, good job. A smart trig class. They're all positive in quadrant 1. Sine's positive in quadrant 2. Tangent's positive in quadrant 3. I said sine, so the answer's negative 1/2. We got to remember that also. They see what we're doing. We're going to do some more of these because we need the review. We also need to do some memory work. Okay, so let's just throw some more out there. Okay, let's say that we had the tangent of 3 pi over 4. Now, the first thing you need to think is, as we go back into our degree stuff, that would be what degree angle? Well, 180 divided by 4, 45. So my reference angle is 45. Where am I at? This is pi. It's 1 pi, which would be 4/4. 3/4 is a fourth away. How much is a fourth? 45 degrees. I'm 45 degrees, I'm setting right here, away from pi. A fourth or 45 degrees away from pi. So I'm setting right here with a reference of 45. And I'm talking about tangent. What's tangent 45? 1. But a smart trig class, tangent is negative in quadrant 2. Okay? Negative 1. I see what we're doing. Okay, so it's the same thing we did with degrees. We just have to convert from radians to degrees real quick. But we still got to remember all the other stuff that we did with that. Okay, so let's go back to our worksheet now that we've done that. And let's do the other 2 problems on that worksheet. And then later we'll rebuild the whole unit circle stuff. We've pretty well done what we need to do. So but I think we'll take the time to video a little more. We've got tangent 7 pi over 6. That's just what we did a while ago, isn't it? Same example. I didn't mean to make up the same one, but we'll do it again. Number 5 on your worksheet. Tangent 7 pi over 6. What's the first thing we want to think? Well, if we haven't memorized all our radian stuff, we need to convert it in our mind to degrees. So what degree goes with 6 as a denominator? 30 degrees. And we're talking about tangent. Now, we also need to know what quadrant. Pi is 6/6. So 7/6 is 1/6 past that, and a sixth is 30 degrees. So we're 30 degrees past, we're sitting right here, right? That's where my 7 pi over, I missed, sorry. We're 30 degrees past at 7 pi over 6. We're talking about tangent 30. What's tangent 30? Square root 3 over 3. Tangent 30, square root 3 over 3. A, smart, trig, class. Tangent is positive in quadrant 3, so it's positive square root 3 over 3. You got to know some stuff to be able to do what we're doing. This all comes out of our head, okay? Any questions on that? All right, let's look at number 6. Number 6, we have 5 pi over 3, sine. Number 6, sine of 5 pi over 3. First of all, we want to think, if we're going to convert in our mind to what we know in degrees, we're going to think a 3 goes with what as an angle? 60. 180 divided by 3 is 60. So my reference angle is 60. Now 5 pi over 3. Here's my pi. This would be 3 pi over 3. I'm 2 pi over 3 more than that. Now, each pi over 3 is 60 degrees. You see that I'm 260 degrees is more than that? That's 120 degrees more than right here. Okay? There's 15, 30, 45, 60, 75, 90, 105, 120. I'm 120 degrees more than pi. You see, I'm actually just a second. I'm actually almost to 2 pi, which means that I missed again. My reference angle is 60. I missed again, and I'm recording. I'm 60 degrees away from having gone all the way around. Now, what is the sine of 60 degrees? Square root 3 over 2. But we have all sine, tangent, cosine is sine positive or negative in quadrant 4. Negative, so my answer is negative square root 3 over 2. So we need to know what's positive and what's what quadrant. We need to know how to go from radians to degrees. We need to be able to understand our fractions enough to know 5 pi over 3 is going to end up in what quadrant. We're going to have to know what the sine of 30, 45, 60, and 90 are, the cosine of 0, 30, 45, 60, and 90, and the tangent of all of those. Okay? So we have a ton of memory work, really, that we have to have in our mind to be able to do this particular sheet. You look at this sheet, what we've done so far, and you think, well, that's not that big a deal. If you look at the amount of writing we put on paper, we didn't put much writing on paper. It all came out of our head pretty well. Any questions on what we did today? All right. Appreciate your attention.